Okay, Wildcats, so we're in Activity 2.2 Linear Programming. Brad is a distance runner who wants to design the most effective workout plan to prepare for his next race. To adequately prepare for the race, Brad plans to do a combination of running and strength training. He must run between 3 and 6 hours per week and wants to devote at least twice as much time to running as to strength training. Brad can spend no more than 8 hours working out each week. Write a system of linear qualities to represent the constraints of the problem situation. Be sure to define your unknowns. X is the number of hours running per week. Y is the number of hours strength training per week. Right. So here we have between 3 to 6 hours per week. That's this inequality. Okay. He wants to devote at least twice as much time running as strength training. That's this inequality right here. Okay. And then he wants to spend no more than 8 hours working out each week. That's this inequality right here. And then X has to be greater than or equal to 0, and Y has to be greater than or equal to 0, okay? Because you can't have negative hours. Okay? So now let's go ahead and graph, okay? Well, to graph 3, X is between 3 and 6, we draw vertical lines between 3 and 6. Okay? And it's between, so you're going to shade between. Okay? All right. Now, to graph this, technically this is plus 0. So we can start at 0 and go up by half. Okay, so we start at 0, and we go up 1 to the right 2, 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 up 1 to the right 2. Okay. All right. Now, it's less than, so we shade below. Now, you'll see the overlapping region, and that's the important. That's where our solution is going to lie, in the overlapping region. Okay. All right. Now, for the x plus y less than or equal to 8, the way we're going to graph this, let's let x equal 0. So that means 0 plus y is less than or equal to 8. So y, and let's just ignore the inequality aspect, and let's just worry about the equal part, okay? So y equals 8. So your point is 0, comma 8. Okay, so 0, comma 8. Okay, now let's let y equal to 0. So you have x plus y less than or equal to 8. And again, we're just going to worry about the equal part, okay? But y is equivalent to 0. So x equals 8. So your point is 8, comma 0. All right, so 8, comma 0. Now, it's less than, so you shade below. Now, you can see that overlaps there, but we're looking for the overlapping region for all of it. So you're looking for when it really overlaps. Okay. And then x is greater than or equal to 0. So that's all this region. And then y is greater than or equal to 0. That's all of this region. So your darker region, this region right here, surrounded by these points, is your solution right here. This region right here. Okay? All right, so go ahead and finish that up. All right, let's take a look at this page. You can use the intersection points to determine the optimal solution to a system of inequalities through a process called linear programming. A linear programming, the vertices of solution region of the system of linear inequalities are substituted into given equations to determine the maximum or min value. Label the vertices of the shaded region. Now to do that, let's go ahead and graph this in Desmos, okay? So 3, move this out of the way, is less than or equal to x, less than or equal to 6, okay? The colors aren't going to be the same that I use, but it'll work. Y is less than or equal to 1 divided by 2x. Make sure the x is right here. Okay, and then x plus y is less than or equal to 8. And x is greater than or equal to 0. And y is greater than or equal to 0. Okay, so you can see here, here's your region, right here. So we want this point, this point, this point, and this point. Okay, so those are our points. Okay, so there are our vertice points. Okay. Now, running burns 600 calories per hour, while strength training burns 250 calories per hour. Write an equation to represent the relationship to be sure to define your variables. X is the number of hours running, and Y is the number of hours strength training. So that's 600X plus 250Y equals W. All right, let's take a look at the next question. Use the vertices of the solution region to determine how many hours Brad should devote to each type of exercise in order to maximize the number of hours burned. So we come back here. That's your point right here. That's your maximum point, the highest point right there. Okay, so Brad should devote 5.3 hours to running and 2.7 hours to strength training to maximize his earnings. All right, let's take a look at the last question. Number 6. A sponsor wants Brad to advertise their company by wearing its brand name on his workout gear. They will pay him $15 for each hour he wears the brand name while running and $20 for each hour he wears the brand name while strength training. Determine how many hours Brad should devote to each type of exercise in order to maximize his earnings. So we're going to put in each of these vertices points to find the maximum value. So we're going to do 15 times 3 plus 20 times 6 equals. We're going to do 15 times 3 plus 20 times 1.5. We're going to do 15 times 5.3 plus 20 times 2.7. We're going to do 15 times 6 plus 20 times 2 equals, and then we're going to do 15 times 6 plus 20 times 0. And let's go ahead and use Desmos to get those values, okay? I'm actually going to go to Desmos, leave here, and I'm going to go to Math Tools, Scientific Calculator, and then so the first value is 165, so I don't have to, and then I'm going to do 15 times 3 plus 20 times 1.5, 15 times 3 plus 20 times, oh, I'm sorry, that's 5.3, and 2.7, that's 133.5, and then 15 times 6 plus 20 times 2 is 130, and then 15 times, oh, plus 20 times 0 is 90. All right, minor typo I just caught. This point is actually supposed to be 3, 0. I misread the 6 to be a 0. Apologize for that, but we'll fix that here, and then we're going to come down here to 20 times 0. Okay, so let me come back over here, and that changes that. And it happens sometimes when you're working problems. Sometimes mistakes happen, and it's important to go back, double check, and sometimes and try to catch your mistake. Okay, so you'll see here that this is your max value right here. Okay, all right, go ahead and finish that up. All right, so here's your assignment. Go ahead and complete that, and have a wonderful Wildcat day.